So we have an exit ticket today on what we're going to do here. I'll just tell you now, there's two options. One is a 1-point option. One is a 2-point option. Concept is the same. The only difference is the 1-point option doesn't have any variables in it. While you're freaking out and you're seeing variables and it's the same math, it's the same exact process, because there's no variables. So you're struggling with understanding when we have variables in, just choose the 1-point option. If you get the fact that variables are just numbers and we don't know what that number is yet, and we do the same math with it, then choose the 2-point option. It's not really any harder other than that. All right, so with that in mind, first question, Catherine, what does bisect mean? Say bisect mean. Bisect mean in general. So if you don't know a word, we've used bisect many times. So write it down again. Listen, what's bisect mean? Come on, people. What does bisect mean in English language?
The line that divides two and
Well, dividing it into two. Some people have said dividing it in half, which is even a little better. In math, though, we need to understand. Here's what you need to write down. Bisect means you're splitting it into two equal, use that word equal, parts. Because that'll then tell you just set those two things equal to each other when you need to write an equation. We've done bisect many, many times. Not new at all. Or something. So a midpoint bisects something into two equal segments. We could bisect an angle. We could bisect a line. We could bisect a shape. You don't normally use it like that, but it's two equal parts, two equal halves. All right, so here's what we did yesterday. A lot of people did not draw that, so I hope you drew that figure out. Write in the AB equals 10, DB equals 7, also on the side. So I'm going to start back over here. Catherine, what can you tell me about that figure? Again, what it gave us some information with the markings, what the markings mean. That and that. You got to know what that means, bro. What's that mean? I'm Catherine. So you should have markings all over the place. You need to write it again. Well, what's that mean, Kristen?
Kevin Hendrick. That's what it's an honor to serve in Pinellas County.
Yeah. So well, they're congruent, but they mean ultimately that side, AD, is the same length as DB. So write that down if you didn't know it. Like we are way too far into using congruence marks to not know that. You're showing you have to put a whole lot of work into what we've been doing. I don't know what.
Oh,
So we did a whole lesson on side, angle, side, 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 side. All it was about was congruence marks, meaning things are equal. So, so now that we know those two sides are congruent, Maria, what else can you tell me about that shape? Well, it does, but let's focus on the fact that those two sides are congruent. We'll come to the right angle later. What kind of shape is it? There is a triangle in it that uses the left and the right side. So what kind of triangle is it? How come you would know? So find in your notes. We did a whole boy. This is really fun. Close enough. Tomorrow I'd find out. Gotta know. Again, can't pronounce it. That's one thing, but we did it yesterday. We did it last week. We did an exit ticket on it last week. Bunch of Excels. Or for the night. Isosceles. Thank you for it. I'm trying to get started. So that is an isosceles triangle. Definition is two sides are congruent, but then we also have to know if those two sides are congruent. Nathan or Nathaniel, either one. It's Nathaniel has hand up. What is also true? This is what you have to connect. Not going to be given. Which two angles? Well, give me letters. Well, not that many. Where's A? Not A and D. B. So again, really getting worried. Friday, again, it goes on next quarter, so you got some time. But if you have a triangle, ignore the middle line. You have a triangle, and you know those two sides are congruent. It should be automatic. Like you haven't put much effort into the last week. If it's not automatic, we've done this for a week. Automatically, you should say those two angles are congruent. Shouldn't have to think about it. Doesn't matter that there's a line down the middle. Doesn't change anything. Just because I draw something in now doesn't change the fact that those are congruent. The only thing that could make it is if they weren't the left and the right side. We said just turn your paper, turn the image so that they are the left and the right side, and then it's the two bottom angles that are congruent. I'll tell you right now, I haven't graded this class. On the exit ticket where we did isosceles, triangles, and what's congruent, and I gave a 1.1 that was no math. In one of the classes, nobody got it. Not a single person got the 1 point question. And all you had to do was say, okay, well, if I know that's congruent to that, I just need to, and I forget how it went. Like Y was here, I think. I don't remember how. Anyway, there was no math. You just had to know which two sides were congruent, which two angles were congruent. And nobody got it. So that's a lack of effort. Like I gave a whole IXL on that you could have done. And the IXLs would have been fine for that level of pressure. They're normally too easy for my quizzes. They're normally fine for exiting. So if I give you stuff, if you wind up not doing as well as you want in a quarter, there's stuff out there you can be doing. I don't know what else to do for you. So we'll get into another one where we have to turn the image. I'm not going to do it here. So I know these are congruent. So here was the big takeaway from yesterday. We said if we have an isosceles triangle and we draw a line from the top vertex down to the base, so the base is the bottom. When we have it set up like this, where the left and the right sides are the congruent sides, the bottom angles are the congruent angles, the bottom is the base. If we draw a line perpendicular to the base, what does that line do? Nathaniel, can you answer that one? The lesson yesterday. This line here, I guess I can do it in red. That's fine. We said that line does something to the base of the triangle. Exactly, it bisects. That's why the whole word bisect is the first question. That red line bisects. it creates two equal line segments at the bottom. So therefore, if we know AB is 10, it told us right there, we know this red line bisects it. That's how you solve for what I asked for, CA, CAAC segment. So the answer is 5. So again, the 1-point exit ticket with no variables is based on that kind of concept. There's a little more to it because it's on a coordinate plane, which we started yesterday, but same concept. All right. Next question. And again, I did a video at the beginning of the year that probably half of you didn't watch. It was about variables in geometry. Still lost on variables in geometry. Some of us. Going up. Can you tell me the answer to number 3? How long is that line segment? The whole line segment. It's not. The bot number 3, that whole line segment from the end point to the end point. You tell me how long it is. If you can't, that's fine.
It's A.
So it is. That's exactly what it is. So let's talk about what you just said. So I'm still on you. How long is that segment right there? It's A, right? That's what these A's are. We don't need numbers. I mean, we'd like to have them. But we can still use the variable. It's some unknown number we don't know. This line segment is A units long. We don't know the measurement of lines. Again, I would love to know what number A is, but I don't. So we just call it A. So what are they telling me when they tell me this one's A and this one's A and this one's A? You just add them up. That's all you do. And they're also telling me they're all the same length too. If they're all the same variable, well, that variable's always got to be the same number. A can't be one number here in the first segment and then a different number in the other segment. So we have 4 of the same number. So you can think of it a couple different ways. It's 4 A's. Or you can do the math like A plus A plus A plus A is the length of that line segment. But what's the shorter version of writing A plus A plus A plus A?
4A.
Yeah, so it's 4A. Again, do not get hung up that there's variables and stuff. I'm telling you now, as we move forward, especially second semester, you're going to get a lot of problems where all you deal with is variables. This lesson today, there's not a lot of numbers in it. There's almost always just variables left over. Variables cannot disappear either, by the way. We can't say the length of it is 4. No, the length of it is 4A. The A can't just disappear. What's the midpoint of it, Jael? What's the midpoint of that line segment? What's midpoint mean? So this would be the midpoint.
Yep.
So how long is each segment? Midpoint is at what? So what's the length of? So it's just 2A. That would be at 2A if it was like an x-axis. So we treat them just like numbers. Just you're going to have a variable in it when you do the math. A plus A is 2, but then we still have the A in it, 2A. 4 A's is A plus A plus A plus A, 4A. Don't forget the variable. A lot of kids have been leaving the variable out. All right, so I'm just going to go into an assignment I created. I've already assigned it to all of you. It's for the quiz Friday. You go through and practice, especially some of the ones that look like what we do in class. You should be good on this part of the quiz Friday. It's on, so again, I didn't write it down. I guess I could now since I'm recording. So here are the topics for Friday. There we go. So all the congruent stuff, Side angle side. So probably give me 2 or 3 questions from that. That would also include knowing how to write the name of 2 congruent triangles. Like remember, you got to match up like the correct angle and the correct angle, or the correct side and the correct side. So that was in IXL. Oh, and this is coming straight from IXL. I'm probably just going to pull those exact same problems from IXL, same ones you were supposed to practice in class. And you should have hopefully somewhere in your notes what the codes were. I think that was maybe LER, maybe. Then isosceles equilateral. And that's triangles. Isosceles equilateral triangles. I think that code was HPR. So again, some of the questions I choose might be harder for that one, but some of them will match up with the IXL. Then we move into kind of what we're doing now. Like we'll move into today's lesson. So triangles on the coordinate plane, which we started yesterday, we'll finish today. And then the last thing that I'm not sure about would be triangle, what's called relationship, side relationship. But it's the thing where I said, can you make a triangle? Like, can that make a triangle? Or what range of values would make a triangle? And we did that the other day. That I'm not sure about. That may not wind up going on there though. We already tried to put that. Somebody, did you ask me on? Oh, so go ahead and you go. All right. So that's your quiz for Friday. You practice, it shouldn't be that bad. If you don't practice, yeah, we'll probably do that. Probably be at least 10 questions. Well, we didn't have a quiz last week.
Yeah, I noticed. I wasn't here last week.
Yeah.
I don't have one.
All right. So let's go into. What in the world? Oh, got it. There we go. All right, so copy this figure down. I'm not even really doing the questions. I'm just trying to show you how to read these types of images. Oh, make sure you notice what is this drawn on? Your third. What is this drawn on? Yeah, it just because there are no grid lines doesn't mean it's not a graph. It's got an x and a y axis, so it's a coordinate plane. Again, just writing a bunch of notes and words without those images is not going to do much good. Well, we're just going over the, just draw it for now. I'm gonna ask you a question. Oh, hold on just a second. You should be able to fill something in though that's not already in it, just based on isosceles triangle. Before I even ask the question, do what you know. Remember, you don't have to wait for a question. Do what you know. You know there's two sides that are congruent. You should know something else. This is your yourself very. Well, one person is out, so depending on how you consider it, yeah. So next is Jason and you.
What did your friends?
Oh, I didn't know that. I just read that this morning when I
Yeah,
turned it around. But yeah, I have a dog. So
this is what
my mom has
oh, girls.
boxing through the snows.
Very best.
Yeah, my mom. It was my Christmas present. All right. So was there a question? And I said, Chloe, no question.
Just need to know what to write down because I've wrote down
Did you draw that image?
should write it.
Okay, that's all you need for now. Then.
Other stuff.
Robert quiz.
It's recorded, so you'll be able to go back and look at it, but I'll show it again in a minute. Let's go ahead and move through it, and then I'll let you at the end of the class just remind me. All right, so what can we write in? I don't even know where I was. Gene, my main man Gene. What can I write into this? If I know those, well, just tell me first of all, what do we know is true? What is? Good, I'll say. Oh, well. So, Dean, what's congruent? So, what part? Those are what though? Just they're the what? Oh, sides. The two sides are congruent, right? So again, as soon as you see two sides are congruent, you need to think it's an isosceles triangle. But more importantly, what else has got to be true, Troy? If I know these two sides are congruent, or any two sides really, what else has to be true? Well, the sides would never, remember sides, I got to go over all that stuff maybe tomorrow. Sides never equal 180, that's ending. But if I see two sides are congruent, they're the same length, but what else that's not given to me do I need to know is true? Or an isosceles triangle is. Give you a hint. In order to figure out which ones, it's helpful for me to turn the triangle so it looks like this. So I turn it so that it's the left and the right side that are congruent. So that means that would be C, B, and A now if I turn that. So now, what else should I know is true in that triangle? If the left and the right side are congruent, what else is true? The bottom ones. Not length. It's not about the side. We don't know the side. First of all, the side's longer. You're on the right track. Don't give up. What's true on what something else is the same. It's not sides. Yes. Look at the picture. Oh, you don't look. You have any notes at all on this? Go ahead and answer.
Um,
That. The two angles at the bottom. That's the main thing you got to know as soon as you see the picture. That's like, I need to know this to pass Mr. Gill's quiz for this stuff. And the other stuff gets you to C's, B's, and A's. And there'd be algebra behind it. You set the two angles equal or the sides or something like that.
Gill, does it matter which angles are the same?
Absolutely. That's why we turn the triangle.
Gotcha.
It's the left and right. So that's the way you always want to set it up. They might give you the two angles are congruent. So you turn it and make the two angles the bottom two angles. Then it would be the left and right side that was congruent. But you always want to imagine it like that. Two bottom angles, left and right side. And then whatever they give you, you just turn it however you need to turn it and fill in the rest. So if we now turn it, well, we don't really have to turn it back. Angle B and C are the two angles that are congruent now. So it'd be those two. And you can just turn your paper. You don't have to redraw it. Just turn your paper, put in the marks, and then turn your paper back. All right, so that's the first thing.
I've got one more question. Do they always put the longest side on the bottom?
It will not
They
always be the
turn it.
longest side.
Okay, for the hypotenuse.
It's the, well, it doesn't even have to be a right triangle, so it won't even be a hypotenuse.
Okay.
So it's just the two sides that are congruent, or the left or the right.
Okay.
If they don't give you sides and they give you angles, the two angles go at the bottom. They'll always give you one or the other, either two angles that are congruent or two sides that are
Does everybody get that?
All right, so next. So here's where we get into the new stuff. It's got variables, but treat it like numbers. Think of it, what if it was a number? I want to know, where did I end up? Troy. So Chloe, you've been gone, but I'll ask you. I want to know the length of this line segment down here. I want to know the length of that line segment. Can you tell me what the length of that line segment is? If not, just say no. Okay. So let's think about this. Because again, it's an X and a Y axis, right? What if this coordinate wasn't that? What if they told us it was 3, 0? So they put a number. Can you tell me now what the length of the bottom side is? It's 3, right? Because it goes from 0 to 3. So everybody got that, right? If it was a number down there, pretty sure you'd all get it. What if I made it, oh, really? 10. What would the bottom, so Becky, what would the bottom side be? How long? 10, right? Why do you all get it when they're numbers and then you not put a variable in? You're like, oh my God, world just starts spinning the opposite direction. This is the X value. I don't care that I don't know what it is. That's the X value. So C, what is the length of the bottom segment? It's B. It doesn't have to be a number. We do problems all the time where they give us the length with variables. 2x subtract 10, 4x plus 7. And I say that is the length of the side. A side doesn't have to be a number. It can be an unknown value, which is all this is. That side is B. Now, we'd love to be able to solve for it later, which is the goal, set up an equation to solve, but sometimes we can, sometimes we can't. So that is B. Eurydia, what's the length of this side? It's also B. I know that two ways. One, they're congruent. So that one's B. Or if this is the X value, right? Every ordered pair is just an X and a Y. That's how I got this value here. It was the X. Well, up here, this is also an X and a Y. So if I'm going up to whatever B is, again, don't need to know the number, that is the length of it. I went from 0 up to B. So the length is B. And don't get so hung up on variables. They work just like numbers, only we just don't know what the number is. All right, so that's any question. Oh, really quickly, anytime you have the X and Y axis in an image, you do need to know that those are perpendicular. That's a right angle. They're not going to draw a right angle in. X and Y axis are perpendicular. So just make sure you understand that also. So that's a right triangle. Any questions on that? All right, so here's the next one. I'm going to go a little faster on these next couple so that we have time for the exit ticket. I'm going to go with 1140. We go with 1140. Troy likes to rush me on. Make sure he gets out on time. Come on. So similar concept. You should know something immediately when you see that figure. Draw that in. We'll draw the figure first. Quickly. Have to be perfect, just as long as you got the X and the Y and the correct numbers and markings. So while you're writing it down, has anybody done writing? Seems the first person. You done? What do we know about that? What? What's the same in that image? So the left and the right side are the same length, right? So those sides, that side is the same length as that side. But what do we also know that they didn't tell us? The base angles. Once you have it aligned where it's the left and right side, and again, this has got to be automatic. Should not have to think about this part. Those base angles are congruent. You get anything out of this lesson? Well, we've already done that part. All right, now we go on to the rest of them. I don't maybe Jason, you came in a little bit late. So again, this point right here is point B. It's got an X and a Y. That's the X and Y. So if I want to know how long this line segment is, Andre, how long is that red segment? Well, B is the name of the point. It's not part of the ordered pair. So look at the ordered pair. So what is it also in there, though? We can't leave this thing out. Well, not the zero yet. 1/2 is partially correct, but what else is with it? A is a number. The length of it is 1/2. So I'm going to kind of pull it out here. It's 1/2 times A. That's what 1/2 A is. We can't just say 1/2 because it'll change depending on what A is. If A is 2, that's way different than if A is 100. You have to write 1/2 A. Plus, just remember, this is not magic class. Right? It's not magic class. The A can't just disappear. How do you like to just drop off the variable and have it just magically disappear? That can't happen. So if that length is 1/2 A, here's a point over here. How long is, I called you earlier. I'm just going to start random and calling. Jael, how long is the blue segment? So let's talk about length. Can length be negative? You measure something with a ruler, come up with a negative. So the length is 1/2 A. Plus, remember, that's perpendicular, and we said that that would bisect these. Don't forget about that concept. So they have to be the same. So if we said this is 1/2 times A, that one is also 1/2 times A. The negative part just means we're in the negative X values, right? Like that's going this way is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Going this way is just -1, -2, -3, -4. So that's all that means is we're just in the negative part of the x-axis. But the length is always positive. 1/2 A and 1/2. Who am I going to call out for this one? Jason, you've been doing a pretty good job today. It's a little trickier. How long is the whole base of that triangle? Close. What can't magically
1/8.
disappear?
Sorry, 1/8.
1/8. Perfect. So if we know that's 1/2 A and that's 1/2 A, the length of the base would just be those two added together. And again, the A can't disappear. It's like combining any like term. 3x plus 4x is 7x. We don't lose the x. Same thing. All right, last one. I'm gonna do this one pretty quickly, or you guys are gonna do it pretty quickly. Yeah. All right, so I gotta go. I forgot this is farther in. All right, so I'm just gonna go over this one. You can go back if you really want to draw it in, draw it in. So just watch this, and I'm gonna ask questions. So in your mind, try to figure it out. First of all, we know two sides are congruent. I'm just gonna give you this piece since we got to get to the exit ticket. We better know that's congruent down there. Turn the image if you need to, but it needs to be always set up like that, left and right, bottom two. I know this is at 2p. Doesn't matter that it's a variable. That is 2p is the x value. So the length of this bottom side is 2p. I went from 0 to an x of 2p. They want to know, though, what is that question mark? What is that x value up there? How do I do it? Anybody have any idea? How do I find an x value if I have a point on the graph? Like if I had this point, what would I do to find the x for it? You don't move it. How do you find the x for that? No, it's no math. You go down to the x-axis, right? Like the x value for this is whatever number is down there. So if we want to know this x value, what do? We go down to the x-axis. You can draw the line, that's kind of where I was going with it. So I would go down to the x-axis right there. Well, that's a right angle. So what do we say we do when we draw a line perpendicular to the base? What's it do? Finish it off.
Bisects.
Yeah, perfect. We bisect it. So if this whole thing is 2p, each one of those is 1p. And that therefore means that's what this x is. 1p. That would be at this point right here, it would be 1p comma 0, which means that the point up top would be 1p. We rushed through it a little bit, but if you want the 1 point exit ticket, raise your hand. One point. So there's different exit ticket for 1 point.